Hey guys, this is Melcher here, and I'm going to be talking to you today some more about some of the substituent reactions that we've been talking about. This is section 23.4, other reactions. As you remember, we talked about condensation reactions the other day, and the condensation reaction is simply the reaction that has water as a product. Today I'll be discussing other reactions with the organic compounds, and these are the reactions that you'll see throughout this presentation. If you have questions, feel free to write them down or post them in the comments. Here we go. All right, this is just some lengthy things. You can use combinations of reactions. This is how people use it in industry. If you have a product that you're looking for, you can react it with petroleum, natural gases, and other organic compounds to come up with what you're looking for. The first one that we're going to talk about today is an elimination reaction. It just means you have some atoms, you're combining them, and a bond is going to be released. So here is an example of an elimination reaction. It's eliminating hydrogen. You're starting with ethane, and when you put it into a reaction, it makes ethene. You can see that this double bond is formed. It got rid of the single bond. When it got rid of that single bond, those two hydrogens popped off the ethane, and hydrogen ends up being diatomic hydrogen is one of the products. It's called dehydration because you're, D meaning without, and hydrogen, so it's taking off the hydrogen. Dehydrogenation reaction. All right, an elimination reaction. Another example is a dehydration. So dehydrogenation being taking off the hydrogen, dehydration being D without, hydra, water, so taking out the water. You can see that if you take an alcohol, which is pictured here, what will happen in this reaction is the hydrogen from the one side and the hydroxyl group from the other side will combine to form water, and then that bond from the hydrogen and the bond from the hydroxyl will end up sticking together to make an alkene. If you see that R group, it just means it's attached to anything, any other organic compound. Addition reaction, this is where you start with alkene or an alkane, and then you'll end up with something different. Okay, one example is a hydration, opposite of dehydration, where you have water and then you're putting it into the products. Hydrogenation is where you have the hydrogen in your reactants and then you're putting that into your products. A lot of times catalysts will be used in hydrogenation reactions just because hydrogenation occurs really slowly, or sometimes it needs extra energy. So a catalyst boosts that energy, allowing the reaction to get over a sort of like reaction hump, kind of like a hill. Catalysts will push it up the hill in order to find the products that you're looking for. Hydrogenation reactions are used to convert liquid and fats that are solid into room temperature. So you probably have heard of dehydrogenation fats, hydrogenated fats, saturated and unsaturated fats. That's what that's talking about. All right, this is just a table outlining some of the addition reactions. Over on the side, the first side, you'll see that we're talking about an alkene. Like I said, you could also have an alkyne over there. And then it shows you the three different reactions which occur. The top one with the hydration and the water. If you take an alkene and you add water to it, you can make it an alcohol. You see how it's an alkane plus the hydroxyl group, an alcohol. Okay, second one down, if you add the diatomic hydrogen, you can make a simple alkane. The two hydrogens are replacing the double bond. Okay, then we have one that wasn't previously talked about, the hydrogen halide, and halide meaning that it's one of the halogen groups, fluorine, chlorine, bromine, iodine, and the X represents the chlorine, bromine, fluorine, iodine reaction. So let's say we have hydrochloric acid and we're mixing it together with the alkene, then you'll end up with, in this example, the R group off that ethane with the Cl. Okay? And then the last one is a halogen, so that's the iodine, bromine, fluorine, chlorine. And the XX just means that it's diatomic, so that's like Cl2 or F2 or Br2. And you can see what's going on there. It ends up being a 1,2 Cl reaction, so if that was an H where that R group is, it would be an ethane, so it would be a 1,2 dichloroethane. Many organic compounds can be converted to other compounds using oxidation and reduction reactions. So when scientists are making different medicines, working in the lab, making products is not instantaneous as it may seem in chemistry class. There are a lot of times where scientists have to go through a multiple step reaction to change things in order to get the final product. There's not just mix this, and you get your answer. It's mix this with this, get one thing, and then do something else to get another thing, and then step 3 and step 4. Here it's talking about what I just said about how you have to change the different reactions in order to get what you're looking for in the final product. There are a number of different reactions here. Here you're starting with methanol, and you've got your OH. So what happens is it's called an oxidation reaction. We lose 2 hydrogens, this one and this one. We end up with this being a double bonded oxygen, as you can see right here. So we lost the hydrogen, so an extra product down here would be diatomic hydrogen. Then what happens here is we have oxidation, again, gaining of oxygen. And this H group here is being replaced with an OH. So we started here with the OH group. We lost 2 hydrogens, giving us this double bond. And then we gained an OH group. So now we've got this sort. And oxidation again, loss of hydrogen. So we're losing this hydrogen, we're losing this hydrogen, and now we end up with 2 double bonds. So this is just a perfect example of what would happen in a lab. Say you wanted to make carbon dioxide. You could go through all these steps just to find your final product. Here's some other things that happen similar to up here. Just going through all the steps, we've lost the hydrogens here, 2 hydrogens to make a double bond, and that's that. And then when we get over here, we've got another example of that same thing where this hydrogen and this hydrogen are being lost to make this double bonded. So these are 2 different reactions. You can see this one's called the propanal and this is called propanone. So propanal being that aldehyde where the O is right after the last carbon, and propanone being the ketone where the oxygen is off the central carbon. When you're looking at these reactions, you can predict what kind of products they're going to have just based on what's going on. If you have hydrogen at the reactants or if you have hydrogen in products, you're seeing hydrogen in the reactants, it's going to be one type, and hydrogen in the products will be a different type. Elimination reactions, meaning you're eliminating something. Addition, you'll have 2 different things. Substitution, are you taking the starting reactant and substituting the hydrogen for maybe a chlorine? All right, hopefully that cleared up some questions that you might have about different types of reactions. Here's a quick question for you. Which type of reaction normally produces an alcohol from an alkane? If you have an alkene. If you have an alkene and you are trying to get an alcohol, what type of reaction? Hydration. What type of reaction is the following? Where you're starting with an alkyl halide and you're going to an alkene. That's an elimination reaction. You are eliminating the halide from that reaction. If I was drawing it out, I would have a chlorine on one with a hydrogen, the chlorine and the hydrogen would be eliminated, and you would get hydrochloric acid along with your alkene. All right, let me know if you have any questions. You can write them down, you can send me a message, you can post something in the comments, or you can always read your text, section 23.4.